Okay, then here's the question. I think that's it there. Yeah. So I'll click over to the summary form of it. So we need to show that that's a factor. So part A, use the factor theorem. For this to be a factor, then we'll need this to be 0. So we need the value of x to be minus 3 over 2, wouldn't we? So f of minus 3 over 2 is equal to 4 times minus 3 over 2 cubed minus 11 times minus 3 over 2 minus 3, which is 4. Minus cubed is a minus, 3 cubed is 27, over 2 cubed is 8, minus times minus is a plus, 11 3s are 33 over 2 minus 3. The 8 and the 4 go into 8 twice with a minus. So it's minus 27 over 2 plus 33 over 2, which is 6 over 2. Take away the 3 equals 0. So that's what we've got there then. Okay, that's question A. So it's a factor. So write fx as that. So here, part B then. Here, the 4x cubed then. Minus 11x minus 3 is equal to 2x plus 3, which is a factor. It's a cubic, so we're going to have ax squared plus the bx plus the c. So what do we get then? Let's equate x cubes first of all. 4 on this side, and on the other side 2a's is the only cube. So that tells us that a equals 2. And that was equating the x cubes both sides. Here's the x cubed term here, 2a. Next we could do constants, would be good. So minus 3 on this side, or x equals 0 is the same thing. And you get 3c. So we can see that c is minus 1 here. Okay, that's the constant. Now we want to equate either x or x squared terms to get b. So I'm going to equate the x terms and see what we get. No, I'm going to equate the x squareds because there's 0 on this side, which is nice. And the x squareds come from 2b, there, and then plus 3a, isn't it? That's the only x squareds terms from the expansion. So b will equal minus 3a over 2, won't it? Move this over there, and then move the 2 from times to divide. Minus 3a over 2a is 2, so it's minus 3. Oops. Okay, so we got that then. Okay, good. So b is equal to minus 3a, and we've got our values. So what have we got? We've got a quadratic 2x squared here. I'm just going to write it in. Minus 3x. And then c is minus 1. So I wonder if that factorizes. I'm just going to have a look at it while we're at it. It's got to be 1 and 1. If it did, it's not looking promising, is it? So I'm just going to leave that for the moment then, and not worry about the factorization. But there's the quadratic. Okay, good. So that's part B done. Show that this... So for part C, show that this equation can be written as this. Okay, with x equals sine theta. 2 cos 2 theta sine theta. 2 cosine 2 theta sine theta. Plus 9 sine theta plus 3. Let's just write it down. Plus 3 equals 0. Now it's an equation in sine, isn't it? So we need to replace the cos by 1 minus 2 sine squared. That's the double angle formula. 9 sine theta plus 3. And what do we get here? We got 2 sine theta, when we expand the bracket, minus 4 sine cubed, isn't it? Because that would be minus 4 sine squared times another sine, plus 9 sine theta, plus 3 equals 0. So run a minus through the lot, we'll get 4 sine cubed. Then we've got 2 and 9 make 11, so it's minus 11 lots of sine theta. And then it's going to be minus 3 equals 0, which is what we wanted to show. Okay, there's our equation then. Solve this for theta between 0 and 360. So, what have we got then? We'll have 2x plus 3, 2 sine theta plus 3, and we'll have the other one, 2 sine squared theta is up here, minus 3 sine theta, minus 1 equals 0. Now, what about this? Does b squared, is there roots? So b squared is 9 minus 4 times a, which is 2, times c, which is 1, minus 1. B squared minus 4 times a times c, which is a root. It's actually 9 and 8 is 17. So here then, sine theta is equal to, well, this one would give minus 3 over 2. So there's no values there. Also, this one gives sine theta minus b, that's plus 3, plus or minus the square root of b squared. Well, we've just done it up here, haven't we? 17. So let's just put that in. Over 2a, which is 2 2s are 4. So what have we got here? Sine theta is equal to, now the plus value will be bigger than 4 on top, so that won't be in the range of sine theta, will it? Because sine varies from at most minus 1 to 1. So the only solution that can arise is 3 minus root 17 over 4, which is negative, isn't it? So let's draw a circle, right cast. Sine is positive here and here, so it's negative there and there. Draw 2 lines, mark off alpha, the associated acute angle, and simply write sine alpha is equal to 3 minus root 17 over 4. So we can do shift sine on this now. Okay, shift sine of this in degrees mode. Top is 3 minus oops, let me just move that out of the way. Sine alpha equals, we drop the negative if there is one to drop. And there is one to drop, so run a minus through it. It's root 17 minus 3, isn't it? So be careful of that. So it's the square root of 17 with a bracket around it on top, minus the 3 value, close that bracket, divided by 4, close the shift sine bracket. 16.3 to the nearest degree it said, didn't it? So we'll just write 16 degrees. Okay, good. So alpha is 16 degrees. So x is equal to, the first one from 0 to 360 is round to here. 180 plus 16 is 196 degree. And the next one is right around to here, which is round 360 back 16, 344 degrees. So there's our two solutions for x.